Okay, so question 7 is an AC circuit. We are given the supply current, which is taken as reference. That is 10 amps at 0 degrees. We're given the voltage drop across the combination of the resistor and inductor. And we're given the capacitance value. And we're asked, first of all, calculate the impedance of the inductor expressed in complex form. Alright, so what we've got here is we have a resistor and inductor. And that is being given an equivalent, so we could call that R, we could call that L, we could call that Z, we'll call that ZRL. And what we've done is we've been given an equivalent voltage drop across that. So what I would do is I would find out the equivalent impedance of this from the voltage. That's how I would tackle this part. So part A, we're looking for the value of the inductor or the reactance. So Z, let's find out what Z is. So that is the voltage drop across the combination resistor and inductor divided by the supply current. So we're given this, we're given the voltage drop, and that is 150 plus J340, and we're given the current, which is 10 amps. So that's 150 plus J340 divided by 10 plus J0. Because it's J0, we can just neglect the J part. Yeah, we can just neglect the J part and just divide that by 10. So dividing a complex number by an ordinary number, that's fairly straightforward. We just do it individually. 150 divided by 10, that's 15. And J340 divided by 10, that's just J34. And that's in ohms. So we know from the formula for the impedance, so that's ZRC, RL, sorry, and that is the same as R plus JXL. So we can just compare that R must be 15 there, so R is equal to 15 ohms, and XL must be 34J, or J34. Sorry, that's ZL. So now what it's asking is the values of R and L of the inductor. Well, there we are. We've calculated R already, but we'll just restate that. So we'll go B. So R is 15 ohms. And L, well, what is L? Well, we have XL, which is J34. And that is equal to 2 pi FL, right? Sorry, that's ZL. So ZL is equal to JXL, remember? So XL is 34. And then we got 2 pi FL. So let's just rearrange in this equation. So we've got 34 is equal to 2 pi FL. And what we're looking for is we're looking for L. So let's just take this to this side. We got 2 pi FL is equal to 34 L, and what we're going to do is we're going to take 2 pi F and we're going to take it under here. So L, whoops, is 34 divided by 2 pi f. Now we're assuming that this is an AC system in the UK, so f will be 50 Hz here. So L is equal to 34 divided by 2 pi times 50. And what we get is 0.108 henries. So that's our L value of the inductor and our R value. And that was our R value there. So part C, or part 3 I should say, the value of the supply voltage expressed in polar form. Okay. So what we need to do is we need to figure out what the capacitive reactance is, because we have, well, we have R, we have XL, we have the current, we've got C, so from this we need XC, and then we need the total impedance, and from the total impedance and the current we can get the supply voltage. So the capacitance was given as, what was the capacitance again? 200 microfarads. So we have XC is equal to 1 over 2 pi f times c, which is equal to 1 over 2 pi times 50 times 200. And that is 200 times 10 to the minus 6. Do that in your calculator and what you get, XC is equal to 15.9 ohms. So ZC is minus J 15.9 ohms. The total impedance, ZT, that is R plus J, and it's the difference between the inductive reactance and the capacitive reactance. So calculated as 15 plus J. XL, we calculated that earlier on as 34. XC is 15.9. So ZT is 15, so this is in rectangular form. 15 plus 18.1 J. Whoop, I've already put the J. Sometimes I put it before the number, sometimes after. So you can convert that into polar. So convert that to polar, and what you get is 23.5, and that's at an angle of 50.35 degrees. So the question asked for it in rectangular, but we've got it in polar there as well. So now what we need, what we're going to be asked for, okay, so the supply voltage, that's what we were doing. So we've got the total impedance, and now we need the supply voltage. Well, Vs is equal to the supply current times the total impedance. Supply current is 10 at an angle of 0, and we're multiplying that by 23.5 at an angle of 50.35. So we're multiplying the magnitudes, adding the angles. So 10 times 23 is 230.5, and 0 plus 50.35, and that's 50.35 degrees. and that's in volts. And we'll convert that to rectangular. So on your calculator you would put 230.5, comma 50.35, and that comes out at 150 plus 181 J volts. So the next part, part 4, we're asked for the phase angle. So the phase angle here, well, remember that's the angle of the voltage minus the angle of the current, which is, we've got the angle of the voltage 50.35 minus the angle of the current, which was 0, so we're left with 50.35 degrees. Of course, you could have just taken that from the overall impedance here, which is 50.35 degrees, if you've already calculated that. Okay, so part 5, we're asked for the power. So the power S is equal to V times I conjugate. Remember, I conjugate is the magnitude of I, but with the angle inversed. Well, the angle's 0, so the negative of 0 is just 0 anyway. So this is the voltage, which is 230.5 at an angle of 50.35 times the current, which is 10, times the conjugate of 0, well, negative 0, we'll just put it anyway, and that comes to 235 at 50.35 degrees volt amperes. 2.35 at 50.35, and that's kilowatt amperes. Right, you could convert that into rectangular. So that there would be in your calculator, this here. So you go 2350 at 50.35, and what you get is the complex number of that in the form of P plus JQ, and that comes out at approximately this, plus 1809.4 J. So we can say from this, Q is 1809.4 volt ampere reactive, and P, the active power, that's in watts. If you were to ask for the power factor, you do cos of theta. So we'll do that anyway, just for the sake of it. So the cos of 50, is it 50.35, wasn't it? 50.35. So cos of 50.35, and that comes out at 63. 8. So again, not very good, but hopefully that's made it a little bit clearer as to what you were to do with the, well, if I get this right. So you have with the voltage of the combined inductor and resistor up here. So a little bit of a trickier step, but you just do it exactly the same. We're trying to find the impedance And then from the impedance, you have R plus JXL. So you know what R is there. You can figure out what XL is. And from that, you use the equation 2 pi FL equals XL. Rearrange it. So L is equal to this. And then you can find your L. Likewise, if you want to find, we want to find the supply voltage. We want the total impedance of the circuit. So we can find XC, and from XC we can find the total impedance. And from this total impedance we can then find the supply voltage. We know the phase angle there, which is exactly the same as the impedance angle here. And then from that we can calculate the apparent power. The conjugate here, because we've taken our supply current at 0 as our reference, then the conjugate it doesn't really make sense here because it's 0 anyway. So the negative 0 is just 0. And from that, you convert it into rectangular. You can calculate your P and your Q, knowing the relation S is equal to P plus JQ. You've got it in rectangular. So this bit, the wholly real part, is the active power. The imaginary part is the reactive power. And I'm just going to head there and calculate the power factor as well.